In this step, we will create a curved toolpath with tool axis control oriented to a point. Curve 5-axis can create a 3-axis, 4-axis, or 5-axis toolpath along a 3D curve or along one or all edges of a surface. The tool axis can be oriented parallel to existing lines, normal to a surface, normal to a plane, or oriented from a point or to a point. Change your view to top. Select the Toolpaths tab, and under Multi-Axis, select Curve. In the Tool page, select Library Tool. Click on Filter. Change the type to Flat End Mill, and change the tool diameter to equal 0.0625. Then press OK. Select the 1/16 flat end mill and press OK. Enter the comment, curve 5-axis with tool axis control to a point. Select Cut Pattern. Cut Pattern settings determines the geometry the tool follows and how it travels along that geometry. Curve type can be chosen between 3D curves or surface edges when you are not using chained geometry. Cut tolerance determines the accuracy of the multi-axis toolpath. Maximum step sets the maximum space allowed between tool vectors. Additional vectors may be desirable in areas where the tool travels in a straight line for a large distance. Projection set to normal plane projects the curves to the tool axis surface using the current construction plane as the projection direction. Projection set to normal to surface projects the curves normal to the tool axis control surfaces. Click the Select button next to 3D Curves. Change the selection method to Window. Then select Chaining Options. Enable Color Mask and click on the Color button. Select only the dark blue number 9 and press OK. Then press OK again. Drag a window around the world map, selecting all of the map. Set the start point approximately here in Australia. Then press OK. Change the compensation type to Off. Then select Tool Axis Control. Tool Axis Control settings determine the tool's orientation in relation to the geometry being cut. Select Tool Axis Control and change it to 2 point. Tool Axis Control set to 2 point limits the tool axis to terminate at a selected point. Output format set to 5-axis allows tool axis rotation in any plane. Lead lag angle tilts the tool forward or backward in the direction of the toolpath. Side tilt angle tilts the tool right or left while traveling in the direction of the toolpath. Angle increment is an angular measurement between adjacent tool vectors. An additional vector will be added to the toolpath when the angle between calculated vectors is greater than the angle increment value. Click the Select button next to Tool Axis Control. Change your view to isometric and select this point. Ensure angle increment is enabled and change it to 8. Then select Collision Control. Change vector depth to -0.35. Collision control settings determine the tip compensation, establish check and compensation surface behavior, the depth at which the tool cuts along the curve, and set gouge process settings. Infinite Look Ahead checks every tool position against every other tool position in the operation to check for gouges. Select Linking. Ensure clearance is enabled and set to 5. Retract is enabled and set to 4. Feed plane is set to 0.25. and keep tool down within % of tool diameter 300%. Press OK to generate the toolpath. Backplot the operation. Select Backplot Options, enable Display Vectors, and set the length to 0.5. Then press OK. Run the backplot. When backplot is finished, press OK, and then verify the operation. Select the Verify tab, and select Keep Chips. Then select this part of the part. When Verify is finished, minimize the simulation window. Return your view to top and fit to screen. Then toggle the toolpath display off.